Aloha mai kako. Thank you for joining us today. I hope everyone is in good health and good spirits. My name is Jennifer Strahl, and I'm the Honolulu meteorology instructor for the Pacific International Training Desk. We're a partnership between the University of Hawaii and the National Weather Service. And on behalf of my Pacific Desk colleagues based in both Honolulu and Guam, welcome to our initial installment of what we expect to be a long, ongoing webinar series. As coronavirus has shifted so much of our personal interaction online, and personal interaction drives everything we do at the Pacific Desk, I want to warmly welcome every one of you joining us online today. Even though sometimes it feels like an eternity, we have hope that these circumstances are not permanent, that we'll be back to meeting face-to-face as soon as it's safe to do so. But for now, we're distanced, so we appreciate you joining us, whether it's from across the island or across the ocean. We also want to acknowledge and express our gratitude to NOAA and the National Weather Service for their ongoing support of our project throughout this time of travel restrictions, quarantines, border closures. Our in-person training has been put on hold, but we're all busy working to bring more training experiences to the Pacific on a variety of platforms, such as this one. Oops. So we have a wide variety of participants today. We have a diverse crowd in the audience, and some of you may not be familiar with the Pacific Desk. Our primary training programs are located within the Honolulu and Guam National Weather Service forecast offices, and participants from the South and the Equatorial Pacific come to Honolulu for training. Participants from our US affiliates across the North Pacific train over in Guam. And since 2018, we have also hosted cohorts at the Weather Service office in Pago Pago, American Samoa. We invite participants from Pacific Meteorology Services to spend 4 weeks with us in training, where we teach introductory and intermediate meteorology topics. We do practical hands-on forecasting experience for their home islands, and we train on a variety of communication systems as well. Our training audience is composed mostly of weather observers, assistant forecasters, junior level forecasters. So this discussion today is going to be geared towards them, our typical training audience who work in weather service operations. We will have time for questions at the end, and you can ask questions in whatever manner you feel comfortable with. So all attendees are muted right now, but if you wish to ask a question later via your microphone, we'll invite you to later raise your hand. There's a raise your hand on the button on the GoToWebinar panel, and then we can unmute you and you can ask your question. You can also type in questions into the GoToWebinar panel at any time, and then we'll direct those to our panelists as appropriate. And speaking of our panelists, we've assembled a group today to speak about an interesting weather event that occurred exactly 1 month ago. For those of you in our audience who are past participants of our Honolulu program, these are some familiar faces to you. So we have with us today Bob Ballard, the Science and Operations Officer at the Central Pacific Hurricane Center. We have John Bravender, the Warning Coordination Meteorologist, also at the Central Pacific Hurricane Center, and Leigh Anne Eaton, who was a forecaster at the office when some of you completed your training here, but she's now the Emergency Response Specialist at the National Weather Service Pacific Regional Operations Center. Each one of them have worked with our training participants in person, and we're so grateful that they're working with us virtually today. So with that, I'm going to turn it over to our first speaker, Bob.
Okay, good afternoon, everybody. I'm going to get my screen sharing going here. Or actually, I think Jen, let's see here.
Yeah, I can.
Yeah, can you make me the presenter? Yeah.
Happy to.
All right. Okay, can everybody see the first slide? The title slide?
Yes. Yes.
Okay, great. Okay, so today I'm going to take all of you on a, no pun intended, whirlwind tour, quick lightning fast tour of Hurricane Douglas as it came toward the islands, one of the closest hurricane approaches we've ever had on Oahu. And I do want to point out from the outset that anything that you see here or hear is preliminary. We will have analysts that will be going over this system in the postseason, doing a reanalysis of the system and taking a look at all the data. And that will get published in the Tropical Cyclone Report later this year. So just understand that, you know, some of this data is still being looked at, being worked on, and that's an ongoing process. But without further ado, this is the operational best track for Hurricane Douglas. It started from a tropical wave there in the East Pacific on the 20th of July, and then progressed off to the west-southwest before making a turn and undergoing rapid intensification up as it headed west-northwest toward the islands. And we'll talk a little bit about the nuances in the track and intensity in a bit. Made its point of closest approach to the islands around July the 26th before progressing off to the west and getting sheared pretty badly. But the peak intensity, 115 knots, Category 4 system that was out there not too far heading in our direction at one time. And so we were pretty nervous when we were seeing model runs. These are various runs of the ECMWF about 48 to 72 hours before Douglas's arrival. And these are taken courtesy of Weather Bell Analytics. Several runs of the ECMWF in these max 10-meter wind gust swaths showing winds over 100 miles per hour affecting portions of the state. And where you see the pink colors, those are winds over 100 knots. So you have a couple of the runs there showing winds 80, 90, almost 100 knots over the islands, which obviously would have been devastating had it happened. And that kind of shows you why we were so concerned about this system and how lucky we really were. To put it in historical perspective, Hurricane Douglas passed, the center of Hurricane Douglas passed about 30 to 50 miles north of all the islands with a really close approach to the north tip of Oahu up there at Kahuku, only about 30 miles or so off to the north of Oahu. And that's closer than Hurricane Dot in 1959, which passed about 60 miles to the southwest of Oahu. Now, we actually had more impacts from Hurricane Dot because we were on the stronger right front quadrant as Hurricane Dot was moving off toward Kauai. But nevertheless, still really dangerously close to be just 30 miles away from the eye of a hurricane passing north of Oahu. It's still hard to believe. This complicated graphic here, I'm just going to talk about a couple things. You can see a zoom in on Oahu there, and there's a double white line extending north from about Turtle Bay and Oahu. You see 8 nautical miles. We looked at the scatterometer winds, the step frequency microwave radiometer winds, and the flight level winds from the reconnaissance aircraft. And you can see that the southern extent of the step frequency microwave radiometer winds, which is looking at ocean surface winds, was only about 8 nautical miles north of the north tip of Oahu. Just amazing. And only about 24 nautical miles north of the north tip of Oahu before you got into the step frequency microwave radiometer 64 knot winds. So we were within 30 miles of getting hurricane conditions on Oahu that day. Really amazing. And Oahu managed to be relatively unscathed with just some gusts of 40 miles per hour or so up around Laie. And that's a picture on the bottom left corner there of the wind swath graphic from CPHC. It's a little bit exaggerated as it used the maximum extent in all the quadrants, but still you can see how close that the tropical storm force winds in orange and the hurricane force winds in darker orange or red there passed to the north of the islands. I'm going to take you through a really quick step-by-step through the 12Z images of the surface chart from CPHC as Tropical Depression Douglas evolved into a storm and then a hurricane. And you can see that it started off embedded in the ITCZ with a tropical wave there near 120 west on the 20th of July. And as you go forward in time, it intensifies. There it is there with the red arrow. As you go forward in time, it intensifies fairly quickly and reaches tropical storm strength within 24 hours, moving toward the west-southwest. And at that point, they were analyzing winds of 55 knots. It continues off toward the west-southwest on the 22nd of July, and it didn't intensify so much during that period, but at this point, it was just about to become a hurricane in the next advisory. At that point, though, 24 hours after that, it had already reached its southernmost latitude and was beginning its west-northwest track toward the islands. At this point, we were getting pretty nervous because it was intensifying rapidly. We knew that there were some negative factors ahead, but we weren't sure exactly how much they were going to be in play for the islands. So here it is, continuing off to the west-northwest, moving toward the islands, remaining a really intense Category 3 system at that point. It had already peaked and was beginning to feel the effects of cooler water, and then moving closer and closer to the islands off to the west-northwest on that nearly straight track. And this takes us through the afternoon local time, 2 p.m. On the 25th of July, or 0Z on the 26th. This graphic shows the sea surface temperatures, and I have overlaid the track with the dates in Z time on the track. And so the big challenge we had, of course, in hindsight, it's easy to see, but the forecast challenge at the time was, without a lot of wind shear, how much was Douglas going to weaken as it moved over that patch of upstream cooler water? And so that was really on our mind as we were making the forecast. In addition to what the track was going to do, I have overlaid there the isotherms. So where you have green, that's 25 degrees Celsius. Where you get to yellow, that's 26 Celsius. Orange, the start of the orange is 27 Celsius, and then the deeper orange is 28 Celsius. So again, after a period of time there on, say, about 12Z on the 24th, you were going to start to get into cooler water, which was going to warm back up again as the tropical cyclone approached the islands. And so there were a lot of intensity forecast factors at play that made us pretty nervous, and we were trying to decide whether this was looking like a high-end storm or still a hurricane once it got close to the state. There is the actual best track intensity, as you can see with the numbers overlaid underneath the X's. And so there was some weakening after the peak wind of 115 knots. It weakened down to 80 or 75 knots once it approached the islands, but that leveled off a little bit. As you see, once it got over the warmer water closer to the islands, you see the temperatures warming back up, and new bursts of convection occurred, which we'll look at in a minute. And so the intensity popped back up to 80 knots before finally shear ended up ripping the convection off. But it was a little too late, and it shows you that the islands are vulnerable to hurricane strikes coming from the east. Here is a long combo IR visible loop, which takes you through Douglas's peak intensity and then runs you through the point of closest approach to the islands. I'm going to let this loop a couple of times. You can see deep convection really wrapping around the center, a great clear eye, and then it fades somewhat as it gets over the cooler water as it's getting closer to the islands, but still intermittently you see an eye feature. And then eventually, once the system gets past Oahu and north of Kauai and on past, you do see the convection start to get ripped off a little bit. We'll take a closer look at the cyclone here in just a minute, but I wanted to give you a big picture look at what was going on. The next we'll go to the water vapor loop. The water vapor loop showed really strong wind shear was occurring over the westernmost islands, especially in response to the subtropical jet. But as Douglas was approaching the islands and advancing toward us, that subtropical jet was forecast to back up toward the west and get wrapped up into a upper level low, which was developing. And again, you can see that on the water vapor imagery off here to the northwest of the islands. So Douglas was involved in a weak upper level ridge, which was favorable for maintaining intensity, at least in terms of shear, as it was moving over the cooler water. So a lot of times cyclones, when they get closer to the islands, will weaken more quickly than this because of upper level wind shear. But Douglas held on pretty well and kept hurricane strength as it was coming in from the east-southeast. And so here is a step through of some higher resolution imagery as we look at Douglas a little closer up. This was when it was near peak intensity, at 2 p.m. on the 23rd of July or 0Z on the 24th of July. That's local time versus UTC. And you can see a very clear, well-defined eye with lots of deep convection surrounding the center. Really looks like a healthy system at that point. And as I go step forward, here's 8 p.m. or 6Z on the 24th. And then you see the eye contract a little bit, but still lots of convection surrounding the center. There was some hint that Douglas may have undergone an eye wall replacement cycle or a partial eye wall replacement cycle during that period. Then you see the eye contract further and it's beginning to look a little more ragged. The deep convection's not as strong as you get to 12Z on the 24th of July. A new little burst of convection. Now at this point, Douglas is over some cooler water, so the eye is pretty ragged. It's going through pulsy convection, but still a formidable hurricane with 100 knot winds. And you see that as I step forward in time, the eye maintains itself for a while longer before going through another cycle of contracting. The convection was really pulsy as it was going over the cooler water. Eventually, we just lose the eye feature altogether temporarily, and the convection looks a little bit suppressed as things get close. But then Douglas began to approach the water, which was a little warmer, closer to the islands, and you see new bursts of convection beginning to develop. And it's possible that maybe a little bit of that upper level outflow was starting to be enhanced for a while, so possibly enhancing the convection as well as it's getting closer. And I'll step through the images where it's making its point of closest approach to the islands here, and you'll actually see the reformation of a weak eye feature to the north of Molokai and then north of Oahu as a new really vigorous burst of convection blew up that evening when Douglas was just about 30 miles to the north of the north tip of Oahu. I'm going to show you a closer in image, even more dramatic, showing you just how close we were to the really strong convection. And radar was showing winds in that zone of as high as 90 to 100 miles an hour at radar level, so at about 6,000 or 7,000 feet. So it would have been hurricane force winds at the surface for sure if we had been in that. And then stepping forward, you can see the shear begin to rip it apart after it gets past the islands and an exposed low-level center there to the northwest of Niihau and Kauai. Just take you quickly through how the model guidance evolved. This was early in time before it was even classified as a disturbance. I'm not going to go through what all the models show. I just want you to see the clustering of the guidance. The track guidance was in fairly good agreement, even from far out, and we knew that this was probably going to be some sort of a threat to the main Hawaiian Islands, depending on how things exactly evolved. The initial motion off toward the southwest or west-southwest was due to that mid-level ridge, but once that moved out of the way, we were expecting a west-northwest motion to continue for a good long while. So initially, we thought maybe we could get by with a track to the south of the Big Island. And as I step forward from T-7 days to T-6 days, still looks like maybe the best chance would be for it to go south of the Big Island. But things changed quickly as we got to about 120 hours before point of closest approach. You see that the tracks shifted northward, and definitely the islands were in play at this point. The tracks continued to center through T-4 days and T-3 days on the middle islands. But nevertheless, as I'll show you in a minute, that doesn't take the Big Island or Kauai out of play at all. In these kind of situations, we want to keep everybody on guard, and it's well within the margin of error. I'm going to zoom in a little here on T-2 days, so just over 48 hours out. And then you've got the tracks have shifted just a little farther north. The ECMWF was leading the pack here. It had started off south of the islands and shifted north, and then the GFS version 16 parallel had shifted north to be more in line with the ECMWF as we got closer. So not too surprising there, something that we typically see. And the forecast consensus did a nice job at T-2 days and T-1 day, showing really close. But one of the things I do want to point out that I'm not going to show here today is that there was several high resolution models, including some of the guidance that we get from Dr. Chen here at UH, showing leftward turn as Douglas got about a beam with Oahu. The models, the high resolution models, can sometimes feel the terrain and understand the effects of the terrain a little better than the global models do. And so that gave us a lot of concern. We weren't sure if the leftward turn was because that the shear was going to rip off the convection a little sooner, or what exactly was going on there, but it was enough to give us pause, and definitely why we maintained hurricane warnings up for Oahu and Kauai for as long as we did, because we weren't sure about any little leftward jog well within the margin of error, even at say 24 hours. And I'm going to talk about our average forecast error since we're talking about messaging today. One of the things that we always have to keep in mind is not to get too wrapped up in the exact forecast position. So I'm just going to pick one position that we're focusing on. Now, this is the 6Z forecast position on that Sunday when it was just north of Oahu. And so the forecast position at 5 days was over the Big Island, but you can see the average forecast error in green. So you really have to consider at least everywhere inside the green. And our forecast cone is a little larger than the average forecast error. And here's how we actually did. That's the center position based on radar and reconnaissance at that time step. I'm going to go through rather quickly here for day 4. We moved the forecast position a little farther north, trending toward the right answer, but still considering average error, you still have pretty much the whole state at play. Then at 3 days, once again, just a little shift to the north. This is 24 hours later, so you can see we didn't shift the forecast position much. We did have it as a strong tropical storm at that point, and as we got closer, we had to reforecast a hurricane because Douglas was not weakening quite as much, and forecasting it dangerously close to Oahu at that point, and then finally zeroing into 1 day with just 40 nautical miles average error, but that's still larger than an island. You could see you could fit 2 Oahus in there. So it's hard when folks want to know, which island is this going to hit, to tell them exactly where it's going to be, because we know we're just not that good, and that's the state of the science right now. One more slide to show you here. I just want to quickly show you how the convection in Douglas gets ripped off rather violently from strong shear. I showed you that in the water vapor imagery. It had set up and reorganized north of the islands, the shear did. And so as Douglas progressed farther and farther north, it was getting into 25 and 30 knots of shear, thanks to the folks at Sims for the analysis and letting us use this here. The red is the shear isopleths. So you got 25 knots near Kauai and then 30 knots farther north. Did a nice job of ripping off the convection, but it would have been a little late if the cyclone had tracked across the islands. We wouldn't have weakened to below hurricane strength until probably until after the low-level center had gone by. And that's about it for me. There's your whirlwind tour of Hurricane Douglas. It'll be interesting to look at the post-season analysis and see what all went on with this thing. There's a lot more data to look at. And I think our next speaker is John Bravender. So I will.
Great, thank you, Bob.
Okay.
Screen it up here. Okay. Now that we've had that, I guess the background that you have for what happened with Douglas, for those that weren't eating, sleeping, and breathing it for the better part of a week straight. Now that you have that framework in mind, we'll go through some communication considerations or challenges, interesting things that will hopefully help you take away some from this to help with briefings, interviews, anything like that in your situation. So here we jump back a couple of years to Tropical Storm Olivia in 2018. We're looking at the lead time to onset and comparing this with a couple of recent cases for island threats that we've had here in Hawaii to I guess, lay some further groundwork for where we'd be coming from once Douglas was approaching. Olivia, on the right-hand side of the image, is 140 west, which is the Central Pacific Hurricane Center area of responsibility, and that's the area that we take over from. So once a tropical cyclone hits 140, National Hurricane Center in Miami will hand it off to us. We'll start issuing the forecast from here. So the right-hand side of these images will be 140, and then you'll see the state of Hawaii on the left. And here Olivia crossed over 140 Saturday the 8th, and then really had its impacts made landfall across Maui and Lanai on Wednesday the 12th, so 4 days later. Olivia is not necessarily what we typically like to see. It did kind of a drunk stagger approach to us from the east in fits and starts, but overall gave about 4 days lead time to communicate, to help people prepare, and for people to get ready. Another example of, I guess, an atypical thing, but from our recent history, was Lane also in 2018. That was approaching from the south. You can see it down here in the lower right, crossed 140 on the 18th, and it was here for a week. Unfortunately, it slowed down and nearly stalled west of the state, so that led to its own challenges for communications. But the takeaway I want you to have from these is that for the people in Hawaii, they're used to these long lead time approaches to have time to prepare. So Bob showed you the track from Douglas, but here's a tighter look that includes the speed that Douglas was maintaining for each of those time steps. Whereas the labels in the last image were every 12 hours, Douglas was moving fast enough that these labels were every 6 hours. And from the right-hand side, it maintained a good 16, 18, a few 20-mile-an-hour speeds all through. So it didn't cross 140 until Friday morning. That's when we took over forecasting, and we had the impacts expected for Sunday. It's just 2 days later. This became a concern on several fronts. 140 West is one thing that emergency managers use as a trigger point for starting certain preparations. They have 140 as a trigger point, and then the issuance of a first tropical storm or hurricane watch as another trigger point. Well, we picked it up at 5 a.m. Friday, and we put out the first hurricane watch 11 a.m. Friday. So there wasn't that much difference. So that's one thing that we're revisiting, is how early we start some of our partner briefings. From an early lead time, this is an interesting part of it too, given the COVID-19 environment that we're in. There's a lot of other stuff going on too. And one thing that we learned after this is that we didn't start communicating as early as we should have. The state and county emergency managers have an ongoing COVID meeting and briefing. So we joined that Monday of this week. So this was impact on Sunday. We joined them 7 days beforehand on Monday, gave a heads up. Bob showed you the track passing near us. It was a concern. Everybody had to be paying attention to it. Did another follow-up on Wednesday and did our first formal video briefing on Thursday. And that worked well for those people that were involved in the COVID response, but we unintentionally left out many of our partners who had weather concerns but not COVID concerns. So that's one thing that we have to be aware of on our end, is who we're talking to, when we're talking to them, and are we talking to them frequently enough. Another messaging concern with Douglas was with the intensity. Bob walked you through the forecast track showing it going over warm water, intensifying, and then moving over colder water and gradually weakening. At this point here, this is the forecast from 11 a.m. Tuesday morning. And I picked this one. It's still a tropical storm. It's forecast to be peak intensity of a 90-knot hurricane 48 hours out. This was the first TV interview I had done for Douglas with Hawaii News Now. And we're talking about preparations, what people should do, and ask yourself, you look at this forecast, oh, it's a hurricane, but it's going to be a storm. How do you message this? Like, what shouldn't you do? You don't want to say, oh yeah, it's going to be a hurricane, but look at this. By 5 days, it's going to be a storm again, so don't worry about it. You don't have to prepare. Don't want to do that. If you think it's going to be a hurricane too, you also don't want to say, well, those guys are forecasting it to be a storm, but it's really not going to weaken. It's going to be a hurricane. You should do that. You don't want to do that either. You don't want to contradict the official forecast, which is the best information that we have available at this time. You don't want to deviate from that, but you want people to consider the uncertainty in the forecast. And in this case, when we talked about this on TV, it's like, yeah, residents should prepare for hurricane force impacts. That's one of the ways to couch that uncertainty. You don't want to say, oh yeah, our average errors on 5 days are 20 knots, so it could be a weak tropical storm or it could be a hurricane. You don't want to do that. Like, this is what we're forecasting, but you should prepare for this in case that doesn't pan out. And in this case, Bob mentioned going through the period of rapid intensification. We skip ahead a couple days. This advisory from 5 p.m. on Thursday is once it jumped up to that 115 knots. This was the point where its maximum intensity, it just edged into a category 4 strength. This time, 6 hours ahead in the evening, it maintained that strength and then gradually started to weaken. This also leads to an awareness for a difference between the types of briefings that you give, whether it's an interview where you want to speak in short sound bites, make it concise so it fits into the news segment properly without having to be edited. Whereas with, say, a briefing for first responders or emergency managers, you can go into more detail. In this case, for the Tuesday, when we were talking about Tuesday, from an emergency management standpoint, you could say, okay, well, we're forecasting rapid intensification. The forecast has it maxing out at 90 knots and then going down after that. But if it does go through more intensification, like in this case, it ended up being 25 knots stronger, it's starting out here, the forecast still pans out, it still goes through that steady weakening, you end up at a higher point. If it's a perfect forecast for weakening, then you're still 25 knots higher than what the other forecast was. So you can give a little more detail, or put it into context like that for decision makers versus trying to hit for a soundbite. But say you're talking to media for this one on Thursday, the first forecast, on the zoom in on the right-hand side of the image, we have one forecast point at 60 hours out, Saturday night, has it as a 65-knot hurricane, and then 12 hours later, Sunday afternoon, has it as a 60-knot tropical storm. That's it. In that case there, the message that we were having was, don't focus on the exact intensity. You can't tell the difference between 60 or 65 knots from miles an hour, because if we're talking to the public, we're using miles an hour. I use the phrase, you can't tell the difference between 70 and 75 miles an hour. So prepare for those hurricane conditions possible. And as it turns out, it did maintain its strength as it went closer to the state. So preparing for those worst conditions turned out to be, could be important had it stay on the same track and go across the islands. Another thing I want to talk about too is, I guess going back to the timing, is the benefit of having a unified message, coordinated ahead of time. One thing that we did, especially on Thursday, as we're looking at this forecast here, we're realizing that not everybody has heard about this. You mentioned how fast Douglas was approaching, and if people aren't paying attention, they won't have days and days of time to prepare like they did during Hurricane Leigh, for example. And not everybody was realizing what was going on. So talking amongst ourselves, Bob actually came up with I think was the one that suggested it, emphasizing at this point, you have 2 days to prepare. This is Thursday. You have Friday and Saturday. It'll be here Sunday. So don't think, oh, it's on the horizon. It'll be fine. I can put it off. Put it into those start that context of where this is where you are, this is how much time you have. We did that for our interviews on Thursday, and I used the same message on Friday when we had the first statewide press conference with the governor, mayors, and other responding officials. That was the message. Like, this is, at that point, it was Friday afternoon. Like, look, you have the rest of today and tomorrow to get ready for Douglas. After that point, conditions will deteriorate, winds increase, heavy rain is possible. It's just too dangerous to prepare on Sunday. You need to get that done, and you have this afternoon to tomorrow to do it. So also this slide within a slide here, I took from one of the initial briefing that we gave for our emergency managers here. I mentioned we did the 140 briefing on Thursday, kind of had to a little bit before we hit 140, but to get everybody aware of what's going on. So this is from that Thursday briefing, and this was situation overview slide. This was the starting point. These are the 3 key messages I wanted them to take away from it. One thing that we found in communicating, especially during intense situations like a hurricane threat, is that people can't process as much information as normal. In normal laid-back times, they found that people can handle up to 7 different pieces of information. That's why phone numbers started out with 7 digits. They can track that. They have the mental capacity to do that. But when they get stressed out, when there's a very intense situation and their stress levels are high, they can't take in that much information. And at most, they can remember 3 items. So when you're giving a briefing or anything like that for people in a situation like this, remember, try to keep it down to key messages, key items. In this case, these 3 were what the takeaways that I wanted them to have from this Douglas briefing. And also because there's a lot going on, you have to repeat them. I have them here on an introductory slide. You go through them in the context of the briefing. We have a summary slide that includes the same information. If it's a presentation like this, it gets redundant, like, oh, he said that already, I don't need to worry about it. But in a highly stressful situation, it's important to keep hitting those key points that you want people to remember. In this case, as Bob showed, we've been talking since 7 days out. The track has been consistent. It's been changing. It's been very tightly clustered. It's been shifting over the islands, but it's been consistently showing an impact to some portion of Hawaii. It might change, especially with that direction of approach. Slight wiggles in the track could have significantly different impacts to different islands. So everybody in the state has to prepare, but it does look like we could be in for something. And the other 2 items were timing related. First watch could be issued as early as 5 a.m. the next morning, and then rain and wind impacts could begin as early as Saturday night. Our goals within the Weather Service are for issuing a hurricane or tropical storm watch 48 hours before onset. So we're expecting to pick up Douglas we had already planned on picking up Douglas for CPHC forecast and responsibility at 5 a.m. Friday. We were anticipating that it's moving so fast, we might need to issue a watch with that first package. I phrased this slide ambiguously like this, intentionally. The watch may be issued. I didn't say which, whether it was a tropical storm or hurricane. If you remember from the last slide, hurricane just east of the state, a 60-knot tropical storm over us. At this point, we weren't sure what it was going to be. So I tried to leave it generic here. And of course, I got called out on it. One of the emergency managers asked me, oh, back on that one slide, you said the watch could be issued. What type of watch are you thinking? A hurricane or tropical storm? And I said, that's a great question. We don't know at this point. We're holding off. We'll have more. We'll see how the intensity of Douglas goes over the next day, and see whether it maintains its strength, whether it's stronger, whether it starts to weaken, and how fast it starts to weaken. That'll give us a better idea of how strong it may be later on. And as you saw from Bob's portion of the presentation, it did actually from the time I did this briefing, the intensity bumped up 5 knots, stayed there through the evening, and then was slower to weaken as it moved over that cooler water, which gave us more confidence for going with the hurricane watch the following morning. So I guess the takeaway from that, from a briefing standpoint, is even if you don't put the information in there, if you think you can get away with not taking a stand one way or the other, somebody will ask that question. So you better be prepared for what that answer may be. Now, the last thing I want to touch on, what we've learned of, I'm going too long. Sorry about that. Another takeaway from this is, I guess what I want you to take away from this is know what your forecast, or know what you're briefing, know what goes into the forecast, and explain why things are different. In this case, we had a technical problem with wind speed probabilities. We generate these with every cycle, and we've been pushing them with preparedness officials as an objective way to gauge uncertainty as a hurricane approaches. The image on the left is the track showing the track, and at this point, this is from Friday evening, hurricane just offshore of Oahu, 48 hours out. We have a hurricane watch out for Oahu. Wind speed probabilities for hurricane force winds are 0 everywhere across the state. It turns out this was tied in with the way that a new routine they use for creating these wind speed probabilities this season, but that has since been fixed. Thankfully, we saw it here. We saw it in some other early season Atlantic systems, and thankfully they've wrapped that up, so it's no longer an issue. But the question came up during a briefing. Emergency manager asked, wind speed probabilities are 0. How, like, you've always said you're looking at generally 10 to 20%, 10% threshold for hurricane watch possible, 20% or so for a hurricane warning. We're 0. And here we are, have a watch, and the next day we upgraded them to Oahu to a warning. How does that work? And the answer was, well, here, 48 hours out, we're forecasting a hurricane 20 miles offshore of the island. So that was an easy one to address. And he certainly understood the reasoning for that. There's other situations that are a little more difficult. We had those in Lane. But in this case, it was relatively straightforward. But as you're giving a briefing, be prepared for questions like that and be able to explain not just what the forecast is, but know what goes into that forecast, so you can answer some in-depth questions of why do we have a hurricane forecast here and 0 wind speed probabilities, as an example. And with that, I will wrap up my portion of the presentation and hand it over to Leigh Anne to talk about Pacific Region ROC.
All right, thanks, John. Let me just make sure I am sharing the right screen. It looks like I am. So like Jennifer introduced earlier, my name's Leigh Anne Eaton. I'm with the Pacific Region Regional Operations Center for the National Weather Service. And so you may ask, what is a Regional Operations Center? Why do we have one of these? So across the National Weather Service, there's 6 different regions, and we're in Pacific Region. If you can see the map on the screen here, Pacific Region covers from Hawaii down to American Samoa, all the way over to Guam, and then actually all the way over to Palau. So if you read through the mission statements here, I'm not going to read through them, but all of them start with to provide consistent and timely support, to provide timely and accurate notification, to provide timely and accurate notification to this, to that, and then to maintain a hub of communication. So really what my position is as an emergency response specialist is to provide support. And that support can go to FEMA, our FEMA partner, FEMA Region 9, which covers the West Coast states of California, Nevada, Arizona, but then also the Pacific regions areas of Hawaii, Guam, CNMI, American Samoa, and the Republic of the Marshall Islands and the Federated States of Micronesia. And so what we do with FEMA is we act as a technical sort of expert, or we can act on their planning team and help provide weather information and those weather updates to their missions. And so, you know, FEMA's mission is to provide, to help with readiness and to help with recovery. So our position is to provide that weather input to help place those people ahead of the storm, or to help place any of the resources ahead of the storm, or even to help after a situation in the recovery phase. So we'll act as a weather sort of technical expert in that stage. So a lot for Douglas, there were daily communication calls. And again, going back to the pandemic, going back to COVID-19, a lot of things were done virtually. So they didn't send a lot of their teams out. If they could support Hawaii or support the area that potentially could be impacted from far, they would be. And so this led to an increase in coordination calls, in which the Weather Service provided the update from CPHC, from what Bob and John were talking. We took their message and then messaged it upwards towards FEMA. So we do the same thing with our National Operations Center in Washington, D.C. So the National Operations Center for the National Weather Service supports all of those 6 regions that we were talking about. And so then what we do is help the message from the Central Pacific Hurricane Center and the Honolulu Forecast Office upwards to the senior leadership in the National Weather Service. So they're aware of anywhere across the nation that potentially could have significant impacts over a certain time frame. And from there, the National Operations Center and that senior leadership could even potentially message our message upwards towards the White House or more federal partners. So we also support the field offices, and those field offices would be the Hawaii, Guam, Samoa, Micronesian offices. And so in my position as an emergency response specialist, we're able to reach out to the field offices, say the Honolulu Forecast Office, and provide them with either extra manpower. One of my colleagues, Eric Lau, he helped with taking over some of the media responsibilities. Since at this time you heard Bob talk and you heard John talk, a lot of these offices get ramped up really fast, and they need extra personnel to take some of the additional duties that come with a significant weather, or with a tropical cyclone potentially impacting the area. And then another thing in my position, unfortunately, not unfortunately, probably more fortunately this time, we can do on-site deployments to either like the Hawaii Emergency Management Agency and act as that technical person within their setup, providing them with the necessary updates and the necessary information they need to make the critical decisions to keep all of Hawaii safe. So in non-pandemic times, you would see myself as an emergency response specialist likely going down to the emergency management agency area to help with that coordination and with that information update. And one other special thing that we do here in Pacific Region is we also support all the NOAA line offices that are in Pacific Region. So 2 years ago in Lane, there were encampments in the northwestern Hawaiian Islands. So the members of the NOAA fisheries team were really concerned about what this tropical cyclone Walaka or what Lane was going to be doing, because there were encampments along the northwestern Hawaiian Islands. So we work closely with the other NOAA line offices that have missions within the Pacific region to keep them aware of the changing situations or the potential impacts that they may see for their personnel and their different missions that they have. And so it allows them, we try to give them ahead of time data so they can make the necessary preparations to either get their personnel off of these remote islands and to get them to safety. So going back to Douglas, some of the stuff that we did the Pacific Region Regional Operations Center, or what we call PR-ROC, is we provide updates to the National Operations Center that does these daily stand-ups with the senior leadership. So some of the things we like to tell them, all of the IDSS, or the decision support, impact-based decision support services that Central Pacific Hurricane Center or the Honolulu Forecast Office are doing to support some of their city, state, or federal partners. And so then they share this amongst all of the senior leadership. So another thing that we do also is following the advisory packages. We put together smaller packages, easier to read, updates to send to those FEMA partners or to the NOAA line offices and to NWO leadership, just telling them of what's changed between each different advisory package. And so really what the Pacific Region ROC is here for is really to help communicate the message. So communicating the message is key. You can see from this little graphic that the message can only be supported if you have the EMs, the NWS forecasters, so that would be the Honolulu Forecast Office and the Central Pacific Hurricane Center, and the media all on the same page, supporting the same message. So like Bob and John were talking about, and with my position, our main mission is to communicate this message and communicate it clearly and communicate it consistently between all different parties. So I know that was a pretty fast overview of what we do, but the regional operations centers amongst these regions and the emergency response specialists are here just to help support the operations of the National Weather Service in whatever function is really needed. So with that, I think we can pass it back to Jennifer and go over, maybe if you've got some time for questions.
Great, thank you so much, all three of you. We really appreciate it. We do have a few minutes left for questions. We did have a couple come in already. We had a couple questions come in during John's portion of the presentation, but I'll leave it up to any of our panelists to answer. One question was, what about notices in other languages? Obviously, here in Hawaii, we do have quite the melting pot of languages. So I will offer that to anybody who can answer that.
I guess I'll take a stab at it for what it's worth. Unfortunately, that's something that we've struggled with as an organization. We do everything that we send out from the National Weather Service is in English. There's some offices in the East Coast and the Atlantic area who do forecasts in Spanish because there's such a large population there. Here in Hawaii, we have such a variety of possible languages that we don't have the ability or the resources to provide them in other means. So that's, like I said, unfortunately, that's not a good answer for you, Jonathan, but something that we struggled with.
Great, thank you. And we had another question too. Is there PIO, Public Information Officer training, offered to briefing staff?
Yeah, so I can take it from here. So all the National Weather Service forecasters are put through IDSS, the term that we used before, Impact-Based Decision Support Services training. Within these development training, we go through a bunch of the FEMA trainings that includes PIO officer type training, but then there is also an hands-on training where forecasters are able to practice doing briefings, and then I know either John or Bob probably want to speak to how the forecast office handles it.
Well, we've had training seminars. I mean, these go back for a really long time, more than a decade or so. There have been seminars that have either been done here at the office or sometimes at the National Weather Service Training Center, where they put you through some pretty intense media training, and you get asked some really tough questions, and they walk you through how to properly respond to those questions and make sure that you are hitting the key points like John talked about, that you want to make sure that you get the key messages out that everybody wants to know. It's really great training. I've had it 3 times. I would do it again. You really need a lot of practice, and it's great to go through. Highly recommended for those that can get to that seminar.
Yeah, one of the things I learned in the course Bob's talking about, one of the facilitators had also said that good briefings come from experience. Unfortunately, experience comes from bad briefings. So I guess the takeaway from that being practice, just have to dive in, do it, and you'll get better with it. Some practice, and hopefully some training experience if possible.
And practice also comes from having events too, which is good and bad, I suppose. We had another question too, probably for Bob, but again, anyone is welcome to answer. What is the primary cause for Hurricane Douglas to track north of the island group instead of west or south or east?
Yeah, I didn't get too much into the really specifics of the meteorology, and I should note that I was not one of the forecasters during Douglas. I was mostly helping out with the media messaging. The pandemic times have sort of given us interesting roles where we're trying to remain separated and not bring our germ bubbles into ops as much as possible. So in terms of the movement, right, so you see John on his boat there. So in terms of the movement of Douglas, once the mid-level ridge that was steering the cyclone off to the west-southwest retrograded back to the east, Douglas was more or less on a beeline toward the islands. The normal high pressure area, which settles north of the islands for 90% of the time during the summer, was a little farther north and allowed the cyclone to gain some latitude in addition to some other things that we call beta effect and things like that, where the cyclone was climbing and gaining latitude. There may have been some impact on the track with shear, but probably not until it got a little closer to the islands at that point. So it was mostly just following the mid-level flow with a ridge off to the north and northeast, which was allowing it to be on that southwest periphery of that ridge. It was from a track forecast standpoint, other than the fact that it was parallel to the islands, which makes it a nightmare, when you look at the long wind swath, it was pretty much a straight line. And it reminded me a lot of Hurricane Iselle in 2014, which did something similar, but came right on into the southeast part of the Big Island, undaunted as it came in. So something to note that the Hawaiian Islands can definitely be threatened by a hurricane from something coming at us from the east or east-southeast.
Very good. All right, well, we're almost out of time. And if anybody else in the audience does have questions, we certainly can take those after this webinar. Before we close up, though, I did want to show, we do have some upcoming webinars, as I mentioned before, and we would love to have you in our audience again. So let me show you my screen, maybe. Oh, and Roger has his hand raised. So while I figure this out, let me unmute Roger. Or if John, if you want to unmute him so Roger can ask a question.
I'll take care of that. Roger, your microphone.
Thank you.
Yep.
Yes, can you hear me?
Gotcha.
Yeah, I was surprised to hear about that that high-res model trying to make a left turn into the islands that Bob mentioned. Our experience with typhoons approaching large land masses, I guess Hawaii maybe counts, for instance, Taiwan or Luzon, is that if the typhoon or tropical storm hits them at an angle, they tend to try to stay offshore. They seem to feel that landmass, and they will bounce. In this case, it would be bounced to the right. So that might have helped a little bit with how that storm just hugged the coast but did not go over and kind of sought a free way. It appears to be something I've seen in many models, so I'm surprised that that mesoscale model that you mentioned tried to make a left turn.
Roger, I'm not positive, and we can go back and look at that. We'll have to talk to UH. I think that shift in the motion might have been related to when the models were trying to show shear decapitating the storm. And so I'm not positive on that, though. I mean, that's still sort of up in the air and something that we can look at and talk about. I'm sure there'll be some research done on this one for sure. So it nevertheless was made it really important to keep folks on guard as you have this hurricane passing 30, 40, 50 miles to the north, to really have to lock in and let them know that at any point this thing could wobble to the left, 30 miles and could really leave us in a world of hurt Anybody who's been to Hawaii, you can look around and see that we are not ready for hurricane force winds here in the islands. I mean, our construction and infrastructure is not ready for that sort of thing. So something that we're always thinking about here at CPHC.
Yeah, that would have scared me as well. And it's also an angle of attack. So if it was just a little bit more west of northwest, it probably would not care about the landmass and just flop right over it anyway. So that's always the case. You guys did a good job.
Thanks, Roger. That's Roger at the Guam Weather Forecast Office. We do have one last question, if you guys don't mind, and if you all don't mind in the audience hanging around for one more. It's a good one, so that's why I figured you guys wouldn't mind. James in New Zealand says, did you have issues with forecasts entering the public domain from non-official or non-authoritative sources, mainly in advance of what comes from the Weather Service?
I mean, I feel like that's a permanent problem now. We talked about this at the Hurricane Conference IHC a year or so ago, where anybody who's a tropical cyclone forecaster, in this day and age in the information era, you just have to understand that there are going to be folks that are making their own forecast and they're saying things that aren't quite right or whatever. I try to handle that in interviews if I know that I'm hearing rumors or incorrect information that's getting spread around. And that requires a little effort to keep up with what's being said. You got to cruise social media a little bit and look at what people are saying. And then I'll try to make sure that I address those in the interviews that I do. So I might say something like, well, you may have heard this, but I just want to clarify for everyone, this is what's going on. And make that part of your messaging, especially, again, if you know that some bad information is out there. You don't necessarily want to call anybody out directly, but you can sort of indirectly do that by straightening the message out and getting folks back on board with what you're trying to tell them and get them ready for what's going on.
Yeah, and I think to add to Bob, it's that whole building a relationship between the emergency managers, the weather forecast office, and the media to make sure you are all keeping that same message, keeping that stool straight.
Actually, building off of Leigh Anne's answer of having those relationships in place, this wasn't Douglas, but this goes back a couple of years to Hurricane Hector. 2018 was an interesting year for us. It seems like the even number of years are interesting, but Hector was passing south of the islands, wasn't going to be a Hawaii threat, but people were worried. The last major hurricane that we had hit the islands was Iniki. It recurved from the south, and that was 1992. Back, we didn't have as good satellite coverage. We didn't have as good model depictions, and it was a surprise to many people that it took that turn, and people were worried about that. And I had a couple different people from different levels of emergency management call me before one of our video briefings and say, hey, people are worried about this. Gave me a heads up that this is a concern so that we could address it. So we could tackle it head on. I was like, no, here, big ridge over us, it's moving westward. It's not, like, I remember using the phrase, there's very few times I'll tell you for certain this is not going to impact Hawaii, but this will not impact Hawaii for Hector. And that was needed because of those rumors or those other concerns based on, I don't know what they're looking at, but having those relationships in place got that information to us as well, so we knew we could address it.
Great, thank you so much. So that concludes our presentation today. So thank you again to our speakers. As I mentioned earlier, we do have some more webinars planned for the future. We're still working out some details for our September events, as you can see on your screen, but we'll push that information out to everybody once things are finalized. If you'd like more information on those webinars or on the Pacific Desk in general, you're welcome to follow us on Facebook. You can visit our website as well, or you can email us. So again, to everybody in the audience, mahalo nui loa for joining us today, and we look forward to seeing you again online next month.